This is a session for normal distribution. We will talk about an overview for the normal distribution, the shape of a normal distribution, which is bell-shaped curve. We'll talk about the density function for it and how do we calculate the distribution of normal distribution, and then how do we calculate or convert it into standard normal, and finally some probability calculations will also be looked at. So let's begin with the overview. And if I say a variable is following a normal distribution, it would be written as x follows normal with mu and sigma square. It's a symmetrical distribution and it is equally distributed on both sides with midpoint as mu, that is mean of normal, and it has two parameters, mu and sigma square. Mu is the mean of distribution and sigma square is variance, and that is expectation of x, which we write as mu, which is one of the parameter, and variance of x, which is sigma square, and it is another parameter for the distribution. As discussed earlier, it will have a bell-shaped curve, which means it is distributed equally on both sides, and we have 50% probability distributed on both sides of the curve with midpoint as the mu. Normal distribution has a density function which is given by fx 1 divided by root 2 pi into sigma and exponential minus 1 by 2 x minus mu divided by sigma whole square. So you can see it's a complex density, not an easy density to integrate, and values of normal distributions are always between minus infinity and plus infinity. To calculate the cumulative distribution or CDF, we can find the capital Fx as minus infinity to x ft dt, where this t is the dummy variable. Now, not an easy distribution to calculate because of complex nature of the density function, which would be written as minus infinity to x 1 divided by root 2 pi sigma into e to the power minus 1 by 2 t minus mu divided by sigma whole square. So rather than calculating the cumulative distribution for normal, we first convert this into a standard normal distribution and then we find the probabilities. So we can see that over here, the standard normal conversion. Here the variable z is standard normal variable, and we can find it by writing x minus mu divided by sigma. So if we know parameters mu and sigma, the variable z can be calculated. Important point is about expectation of z, which is expectation of x minus mu by sigma. Sigma being constant will come out, and expectation of x is mu, which will give e of z as 0. Likewise, when we calculate variance of z, that would be 1 divided by sigma square into variance of x minus mu, which will give you mu being constant, variance of x would be sigma square, and hence it would be 1. So we have seen expectation and variance of z. Z is also a normal distribution, so z follows normal with parameters 0 and 1. When we talk about density function of z, which is given by the small phi of z or f of z, which is 1 divided by root 2 pi into e to the power minus 1 by 2 into z square, where z is the standard normal variable. If we have to calculate the cumulative distribution of this z, which is given by a capital phi, which means it is f of z, it is nothing but probability of z less than equals to z. We can calculate this as minus infinity to z and f of t dt. So we have pre-calculated probabilities for standard normal distribution, and this is also a bell-shaped curve with midpoint as 0. Since mean of the standard normal is 0, values will also be between minus infinity to plus infinity, and this would be standard normal distribution. We can convert any standard normal to a we can convert any normal to a standard normal variable. For example, if x was normal with mu and sigma square, then x can be transformed to a standard normal variable, and probability of x less than equals to a for example will become probability of x minus mu divided by sigma less than, we can take it as less than equals to a minus mu divided by sigma. So as I said earlier, the probabilities for Z are pre-calculated and available to us in tabular form. We can find these values for probability from the table. Sometimes we'll have to interpolate as well and find the answer. So x less than equals to a, which was a positive value, can be seen here. Let's say this is a here. So we have converted this probability on a standard normal scale, and we are now finding out z less than equals to a minus mu by sigma. If this was the x values and these are the z values which are also symmetrical, so this point here would be a minus mu divided by sigma. So we can look at an example now in order to calculate the probability for a standard normal. Let's say x is a normal distribution and it follows normal with mean mu and variance 64. That is mean 20 and variance 64. So this means mu is equals to 20 and sigma square is equals to 64. If we have to calculate x less than 25, this can be written as z less than equals to 25 minus 20 divided by 8, which is z less than equals to 6 or 0.625. Now this means we are calculating on a standard normal distribution value for probability which is less than 0.625. This can be found between probability of 0.62 and 0.63. So we can find the probability values, that is cumulative distribution of standard normal at 0.62 and at 0.63. We can interpolate between these 2 points to find the final answer. So we have covered more such examples in the numerical section of the normal distribution. You may look at similar examples over there. In case you have doubt in normal distribution or how we convert, you may send a mail to us, or you can also talk to your instructor about it. Thank you very much.